How's it going, everybody? Welcome back to my channel Code with Jugal. In this video, we will look at a problem that is famously known as the search range or the number range, which essentially is that we are required to find the first and the last occurrence of the target element in a sorted array. Let's look at the problem statement in more detail first. So, the problem statement says that given a sorted array of numbers in ascending order with possible duplicates and a number target, write a function that finds the first and the last occurrence of the target in the array. And if no such number exists, then we return -1, comma -1. Let's look at the first example for better understanding. See, here we are given an array 1, 2, 6, and so on, and a target element 6. Our goal is to find the first occurrence of the target and the last occurrence of the target and return its index. In this example, the first occurrence of the target 6 is at index 2, and the last occurrence of target 6 is at index 5. So we return the first occurrence and the last occurrence in an array. So that is an array of 2, 5. Similarly, in another example, the target is 67, and we can see that 67 appears in the array at index 6. So we return a list of 6, 6. In another example, the target is 195, and we see that the target does not exist in the array. So in this situation, we return a list of -1, -1. Likewise, we are given an empty array and target 5. And because the target does not exist in the array, again we return -1, -1. Apart from that, we are given some additional information that the arrays might have duplicates, just like how we saw here. And the array is sorted in the ascending order. Let's see how we can solve this problem. Before we go ahead, I urge you all to pause the video and take a moment to think about how we can solve this problem. Let's get started. As always, we will start off with the brute force solution. Anytime we have a search problem, linear search should be the first tool for the attack. Here, a very nice solution would be to perform two linear searches. One linear search from the start of the array and another one from the end of the array. So for the first linear search, we loop from the start of the array and stop as soon as we see the target element and store its index. Now to compute the last occurrence, we'll do another linear search and start looping from the end of the array towards the start of the array, and we'll keep looping up until we find the first occurrence of the target element, which essentially would be the last occurrence since we are looping from the end. So in this situation, we'll keep looping up until we reach index 5 because that's where the target is. So we have the last occurrence as well. So now since we have the first and the last occurrence, we return them in an array. So the time taken for this approach would be twice the time taken for a linear search since we are performing the linear search twice. So the total time taken would be twice O of n, which in a grand scheme of things is still O of n. Since we know that the array is sorted, we have a very high chance of using binary search to reduce the time complexity. Let's see how we can do that. Just like the linear search, we will do two binary searches. One binary search to find the first occurrence of the target element and another one to find the last occurrence of the target element. The binary search here is very similar to the vanilla binary search, but slightly different in the fact that here we might have duplicates, and instead of returning the index of the target element, we have to make sure the target element found is either the first occurrence or the last occurrence in the array. This example is similar to the one that we saw above, where we are given an array 1, 2, 6, and so on. Our target is 6, and the desired output is supposed to be 2, 5. Let's find the first occurrence of the target in the array. We start off by having two pointers, one at the start of the array and another one at the end. We will compute the middle pointer using this formula. So it's 0 plus 8 divided by 2, that is 4. So the middle pointer is at index 4. Now here the target is 6, the middle element is 6. So we have found our target, but instead of returning the index 4, we have to make sure that this index over here is the first occurred element in the array. So what we will do is that we will have another variable that will store the index of the last seen target. So in this situation here, the last seen target is at index 4. So we'll have another variable called say index of interest. Here the variable index of interest will store the value 4. Now if there is another occurrence of the target 6 in the array, then it has to be on the left hand side of the array. So we move the end pointer before the mid pointer and discard the remaining part of the array. So with the new end pointer, the mid pointer becomes 0 plus 3 divided by 2 and we take the float. So it is 1. So the mid pointer is at index 1. And since the element at the middle pointer is less than our target 6, we move the start pointer ahead of the mid pointer. So the new start pointer points at index 2. We recompute the middle pointer, that is 2 plus 5 divided by 2, which is 2.5, and we take the floor, so it's 2. So the middle pointer overlaps the start pointer, and at this point the middle element is equal to our target. So we update the index of interest variable to 2, which is the index of the last seen target. And like before, if there is another occurrence of the target 6 in the array and we are looking for the first occurrence, the first occurrence has to be on the left hand side of the middle pointer. So in this situation, we move the end pointer before the mid pointer. So the end pointer is moved to index 1. At this point, the start pointer has become greater than the end pointer, which means that our loop has terminated. And index of interest is the first occurrence of our target element, which is what we wanted. Now let's do another binary search to find the last occurrence of the target in the array. Here we'll initialize the index of interest as -1. Like before, we will have two pointers, the start and the end, and we will compute the middle element. The middle pointer is at index 4. Again, the middle element is equal to the target. So we update the index of interest to that index, that is 4. So we have found our target element, that is 6 at index 4, but we are not 100% sure that this is the last occurrence of that target in the array. To find the actual last occurrence of the target, it has to be on the latter half of the array. So to perform the search on the latter half of the array, we move the start pointer one element ahead of the mid pointer. So the new start pointer points at index 5. With this new pointers, we recompute the middle element, that is 5 plus 8 is 13, divided by 2 is 6.5, and we take the floor, which is 6. So the middle pointer points at index 6. Now the middle element is 67, which is greater than the target 6. So we move our end pointer one element before the mid pointer. Again, with these new pointers, we recompute the mid, which is 5 plus 5, that is 10, divided by 2 is 5. So the middle pointer is also at index 5. The middle element is 6, which is equal to the target, which means that we have found a new occurrence of the target, which is later than what we had found earlier. So we update our index of interest to this newer index, which is index 5. Now if there are more occurrences of the target, then to find those occurrences, we have to move the start pointer one element ahead of the mid pointer. At this point, the start pointer has moved ahead of the end pointer. This means that we don't have any more occurrences of the target 6 in the array, and the last occurrence is equal to the index of the interest, which is 5, which is equal to what we wanted in the output. Since each binary search has the time complexity of O of log fn, this means that two binary searches would have the time complexity of 2 times O of log of n, which in the grand scheme of things is equivalent to O of log of n, and the space complexity is O of 1. Let's look at the code to solidify our understandings. Before we go ahead, if you think this video was helpful to you up until now, then I humbly request you to please like the video and subscribe to my channel so that other people can benefit from the video as well. Thank you very much. I have already written the code in Python and JavaScript, and we'll walk through the code in Python. Even if you're not familiar with Python, once you understand the basic structure, writing the algorithm in any other language would be fairly easy. And you can find the links to the Python and JavaScript solution on my repo, that is the coding interviews. The link to the repo is attached to this video's description as well. Let's walk through the code. I have already written some of the examples that we've seen in the problem statement above. Let's take the first example. So here we are given the array 1, 2, 3 and so on. The target 6. Our expected output is 2, 5. That is an array of 2, 5. And we are expected to write a function called search range that takes an array and a target and returns a list. Similar to what we spoke earlier, we will do two binary searches. One to find the first occurrence of the target, and another one to find the last occurrence of the target element in the array. And then we return the first and the last occurrences in an array. Let's see how the search is done. So the search function that performs binary search takes three parameters. One is the array, another one is the target they were trying to find, and a third parameter that is a boolean, that is asking whether do we want to find the first occurrence or we want to find the last occurrence. In the first binary search, that boolean is true, and in the second binary search, the boolean is false because we want to find the last occurrence. So the first step we do is we take care of the edge case first. If the length of the array is 0, this means that there are no elements in the array, so we straight away return -1, which means that the target doesn't exist in the array. Let me draw one of the arrays example so it's easier for understanding. As mentioned earlier, we will have two pointers, one at the start of the array, another one at the end of the array, and the value of the index of interest at the start is -1. Now just like the vanilla binary search, we'll keep looping until the start pointer becomes greater than the end pointer, in which case we won't have the array to divide anymore and we will terminate the loop. The next step is we find the middle pointer, that is start plus end divided by 2. In our situation would be at index 4. If the middle element is equal to the target, we update the index of interest to the point where we found the target. So in this case, the index of interest would be equal to the mid. If we are computing the first occurrence has to be on the left hand side of the mid pointer. So this means that we will move the end pointer one element before the mid pointer. So the new end will become mid -1 when we are computing the first occurrence. And if we are computing the last occurrence, this means that the start pointer should be moved one element ahead of the mid pointer because the last occurrence would be on the right hand side of the mid pointer. So we update the start pointer to mid +1. However, in situations when the middle element is greater than the target, this means that the target would be to the left of the middle element. So we move the end pointer one element before the mid pointer. That is, the new end becomes mid -1. In another situation, if the middle element is smaller than the target, then we move the start pointer one element ahead of the mid pointer. So the new start becomes mid +1. At the end of the while loop, the variable index of the interest will have one of the three values. It either have -1, which means that the target element does not exist in the array, or it will either have the first occurrence of the target or the last occurrence of the target. So we return index of interest. Coming back to the search range function, if the first binary search returns -1, this means that the target doesn't exist in the array, in which case we return -1, -1. Or else we perform the second binary search and then we return the first occurrence and the last occurrence in an array. And we conclude the problem here. Please let me know your thoughts and suggestions in the comment section below. Thank you very much.